Hi everyone.
Hello, Salman.
How's it going?
Double busy, as always.
Yes.
But other than that, very good. How are you?
I'm good, thank you.
Morning, guys. How's it going?
Good morning.
Hello, Imran. You okay?
Yep. Hi, everyone. Let's wait for 2 more minutes before we get started, as some other participants are joining. Hmm. I think we should get started now. Let me share my screen. Recording, right? Yes. Can everybody hear me? Well,
Yep.
yes. Good.
Yes.
Good morning, everyone. My name is Imran Yasin. I'm the chapter lead of this project, which is called Data Science for Climate Change. It's just to mitigate greenhouse gases emission by reducing energy consumption for buildings. Today is July 22nd. This is our agenda going to be. I'm going to introduce briefly myself, discuss problem statement, project goals, learning outcomes, timelines, and some Omdina benefits. First, I'm introducing myself briefly. My name is Imran Yasin. Currently, I'm working as an automation scientist at J&J. I have more than 6 years of experience working in different Fortune 500 companies. I thoroughly believe AI has a great potential to make an impact in many different industries. That's why I'm here, and all of us are here. And I have worked in past Omdina projects as well before, but this is my first time working as a chapter lead, leading up as a chapter. And I have a Gordon Scholar title in UC San Diego, and I've also won a few leadership awards in previous leadership positions before. Enough about me. Background of this problem statement. So according to IEA, International Energy Agency, so the life cycle of building from construction to demolition was responsible for up to 37% of the global energy related and process related CO2 emissions in 2020. Yet we can still, there are ways we can just reduce those energy CO2 emissions by easy to implement fixes and state of the art technologies. One of the ways this is using retrofitted building can help reduce heating and cooling energy requirements by 50 to 90%. Well, those who don't know what retrofitted means, retrofitting means involves the implementation of modification of existing building that improve their energy efficiency or reduce their energy requirements. So it's like implementation of modification of the existing buildings. Any questions so far, anyone? We are good. So the overall challenge, our overall challenge will be to analyze different regional differences in our data set. Data set so far consists of 7 different states. It says, well, I guess I'll cover in a few later slides later on. The challenge participants will analyze different regional differences in energy efficiency, and they will build models to predict energy consumptions. And which is an important step in understanding how to maximize energy efficiency. And in this one, we'll also making accurate predictions of energy consumptions that will eventually help the policymakers as well. So the overall challenge. Some of these curves are taken from part 1. I'm deliberately kept it here to give, there are many newcomers in this part 2. So just to give an idea what we have gone through so far. So some of the stuff here is deliberate. The data focuses here on a prediction task involving roughly, there were 80,000 observations, which was actually in real, there was lower when you see the data sets, which was about collected over 7 years. And there was a collecting, considering the number of states within the US. The data set has building characteristics, floor type, facility type, and many other factors. We'll go over the data in the detail as well later on. And it has weather data for the location of the building, and such as annual average temperature, annual precipitation, whether the buildings are located in a hot climate place or in a warm climate place, and that also affects how much the energy consumption wise as well, and many other factors as well, or how much, whether it's in a humid region or in a dry region, something like that. And as well as the energy usage of the building in a given year. We also compare that as well, and measured as, which is measured as site energy usage intensity. And our task in this is to predict the site EUI, which is energy usage intensity, given the different characteristics which I just described here earlier. We can of course add more as well to enhance further analysis. So in this particular project, since in part 1 we have done some of that aspect already. In part 1, actually, just to give you as a refresher, in part 1 we have covered data pre-processing. So that includes like cleaning of data and making it ready to send it to the EDA. In part 2 we also did in part 1 we did data pre-processing, which includes data cleaning and stuff. And we did exploratory data analysis to make visual representation of how our data looks and where we stand and how we should approach. And then third, we did feature engineering as well to find out the most important feature which is of the highest impact on the energy usage. So that was in part 1, which we did. And in part 2, we'll be focusing on, the team will be focusing on developing, evaluating, and deploying our model using the data sets generated in part 10. I'll give further details in later slides as well on that. Well, the data which we have, well, I guess that's more task 1 specific, like could have been implemented, could have been augmented with meteorological data, like as I said earlier, temperature, wind speed, and pressure, and then we could have made more value on the data, but that was a part 1 part. And one of the key challenges will be to choose appropriate features which has the highest impact on energy dynamics. That's also as taken care in the feature engineering, but of course as a group we can discuss it further in this project. Our ultimate goal is to develop a model that can accurately predict energy consumption, which was called SITE EUI, energy and usage intensity. Some of these supervised learning techniques we could employ, or if there are any more we can consider. These are some of them include AN, SVM, KNN, gradient boosting regressor, extra tree regressor. There are many other few of them we will also discuss as a team, and we can always add on. I noticed there are some at least more experienced people in this group, so feel free to share your wisdom with the group here as well. We can always add more stuff. So part 1, which we did, I guess I covered it earlier. This is what we covered from it was in June, that we covered data pre-processing inside exploratory EDA and feature engineering. And those in this part who just joined us now, I'll share some YouTube links and other resources. They are more than welcome if they want to see what we have done. They can always watch our videos on YouTube to get a sense of what we have done. Each has a specific topic-wise lecture, so it's very easy to follow through. You won't miss anything. We deliberately didn't change our Slack channel, so at least if you want to follow what our conversations went through and how we approach things, so there's a discussion on Slack channel, so you should be able to keep up with that as well. And yes, and in part 2, which will be from July 6th, from today till August 3rd, we'll be developing a model, evaluating it, and deploying it eventually. That was a part 1 goal. I think I already emphasized it enough, but I'm going to quickly go over it. We took care in data pre-processing. We just cleaned the data, removed outlier, treated of missing data, we converted data to an appropriate data type, and we normalized the data, did EDA and did feature engineering. I think I'm kind of redundant now at this point, but standard data pre-processing stuff. In part 2, these are some of the models which we have thought at least we will be deploying, but please don't restrict yourself to this. If you think there are other models from your previous work experience, or if you know you have good knowledge, feel free to share. It's just a framework we are discussing here. We can always add on. So be at peace, please add value. And this one thing I also would like to emphasize, in our project, we kind of customize it based on the participants' need. We don't have like something strict and say, okay, this is all we have to do, and that's all we are going to do. If you have idea, feel free to add value, and we can make it work, so at least all of us get the most out of this experience. In model evaluation, there are a few metrics we can consider, which is R-square, MAE, RMSE, root mean square error, and mean squared error. However, for this project, yes, we are using mean average error so far, but we can always consider more as well if needed. And we'll eventually be deploying, building a dashboard or an app. There are some additional components. So far, we haven't thought of that, but if somebody has expertise, like we can also consider in terms of deploying, we can also use these cloud services like AWS or Google Cloud. So that depends on interest of the participants here. We can also make interactive plots displaying energy consumption analytics of each state, as well as forecast the energy consumption in the past time and estimate the consumption in the future through time series analysis. So this is a rough timeline we plan to focus on in this part 2 of the project. We will be making in this week from starting today on tomorrow till Wednesday of next week. We will be focusing on data pipelines. So we will be elaborating further. I'll give in the next few slides what do I mean, but actually we have done feature engineering in the part 1. Using that, we will create different data pipelines, and then we can I'll let our previous task leads to elaborate more on that. And so we'll be using those different data sets. There will be 10 altogether, which we'll be using that to deploy our model and then eventually evaluate with the matrix I just mentioned early on. So in task 0, it's mainly about creating data pipeline and creating our base model. And from week 2 to week 3, which is from July 14th till pretty much till July 27th, first week we'll be doing the model deployment, or model development, as well as and after followed by model evaluation. So that has to be taken care in these 2 weeks. In final week, I guess I'm going to, after this presentation, in the end, I will keep the floor open, and then as a team, we will decide where do we want to deploy it, whether we want to deploy in Streamlit app, Power BI, Tableau, or if there are some experts here, maybe we can deploy in AWS or Google Cloud. So, which I will let you guys give your 2 cents later on how we should approach on that. So, but this one is more open-ended, and so that will be in a final week. And that will be kind of like a presentation at the same time, since whatever we have deployed, whoever we will be the leads, they can just present it, and that will be the final presentation as well. I'm gonna very briefly touch base on that, and then I'm gonna pass it down to our task leads. Maybe they can elaborate further. So that's when I was saying earlier on week 1 about data, about task zero data pipeline. Maybe I think I should give it to, let me high level cover it, and then I'll give it to task leads. So in task, and this week, basically starting today till next Wednesday, maybe we already have stuff from in a feature engine. Maybe we can use some pre-processing of the data, and we can do some EDA that includes some of these tasks, and then do KNN or simple imputation, and followed by data encoding, encoding, which is like one-hot coding, label encoding, standard normalization, feature engineering. We can pick each of these, RFE, VIF, RFR, LGPM, followed by PCA, model development. That's up to from here till all the way till PCA. That will, on that one, we will be generating 10 different data sets, which I'm going to cover in my next slide. And then these one, we will pick whichever is best, then we will deploy here. I mean, model development as well as evaluation, hyperparametric tuning, we'll do it and then deploy eventually. On this particular one, I think maybe I can ask one of our task leads, maybe they can elaborate more further on this particular slide. Salman or Rich, you want to speak a bit on this?
Yeah.
This particular slide.
Okay, so so in this slide, technically, we have made several different combinations of techniques that we have previously applied on our data, and we have put together 10 different combinations here. Even though there are more possible combinations, but that would be too much. So we are sticking to these 10 combinations. So you can see that we have done some pre-processing, several different steps. That is kind of like pretty much same in all the pipelines. The next one, EDA, that is pretty much same in all the pipelines. Then we tried several different imputation techniques. So we are sticking to 2 basic ones, simple imputation and KNN. So first pipeline or first set of pipelines have simple imputation, where we are just imputing the most repeated values like mode or the mean value or something based on that. And then one-hot encoding, obviously we are doing one-hot encoding. And before one-hot encoding, in this pre-processing and EDA part, what we did is we have already taken care of the number of categories in some of the columns. For example, in one of the column, facility type, there were about 63 categories. So we have already merged up those categories and reduced the number of categories. Along with that, we have already reduced the number of columns in our data, like temperatures. We have converted them into seasonal temperatures. So we will be sticking with that. So based on that, we will just have to apply the one-hot encoding, and maybe I think one of the variable had only 2 variables, so we can whether it is one-hot or what, we can just convert it because since it is 2 columns and we are dropping 1 column, so it's technically label encoding. Then the next one is we have to do standardization or normalization. We would be sticking with simple standardization for now, and then PCA. That would be our first pipeline, and that would be our baseline pipeline, which means we will create a data from the first pipeline that you see over here on the left hand side, the first column. That steps would give you 1 data set, and we are gonna throw it in the models we will run several different models, about 10 to 12 different models, a lot of regression models, and some neural networks. And we will see which models are giving best results or something, and we will note down the mean square error, MSE or MAE, all three values for that particular model. And we would call that model as our baseline model. So now our goal is to beat that model by doing several different combinations. So the next column, if you see what is happening here, we are following exactly the same pipeline, but at the end, instead of PCA, we are exchanging it with recursive feature elimination using regression or any other means. We tried several different ones. We can, we just need to change the estimator in the RFE code, and it can use linear regression, it can use any regularized regression, it can use any tree method, and the recursive feature elimination can be done. So which means using these steps, we will end up with another data pipeline, and that would give us a different data set. So we will be generating 10 of these data sets using these set of steps that we have done, and we will run them all through the model development phase, and we will see which one is giving us the best results. We will do the hyperparameter tuning and evaluation. So our goal is to beat the baseline. So the first column, that is our baseline. We have to beat it because this is the simplest possible implementation of this project. But we are adding extra features like variance inflation factor as a feature selection method. We don't know which one would work, whether KNN imputation and PCA would do better, or simple imputation or PCA would do better. We don't know. So since these are just 10 combinations, feel free to explore further and make more combinations, because there are so many different possible set of data pipelines you can create, and you would end up with a different data, and it can give you different answers when you are running through the models. So right now we are restricting to just 10. What me and Rich, we originally we would be doing the first week is about pipelines. So I will be creating the baseline pipeline today, and I would be uploading it, and I will be letting you know on Slack that I have uploaded it. And I would be recommending you to go and explore or use that data to make some models. I saw that on Slack, Diana applied AutoML. I think TPOD something. So yes, apply AutoML using genetic or something, and a genetic algorithm, and see what kind of results you are getting. So feel free to explore any model you want or any particular thing, and do share with us, because we are kind of like trying to do things as if you can bring in extra information, that would be amazing, because everybody here is for learning purposes. If I have not applied certain things, I want to learn from someone else. So if somebody else knows something, or I have tried something, I want to know it. And if I'm doing something, I will be sharing it with you. If you're doing something, please do share, so that everybody kind of like grows together. Okay, so that is our goal. So everybody kind of like understands what these 10 columns mean. All these 10 columns are technically telling you the steps you would take that would give you a data at the end, a clean data, which you can throw it into the model. But every single column is giving you a different data sets. And when you throw it into the model, the results can be different. And we don't know which one is going to give you best answers. So we need to kind of like figure out what combination is going to give us the best answers. And we will stick with that once we are, we have tuned it, we have evaluated and everything. Then finally, the deployment part comes into play. We will be deploying the best model. So yeah, so that is it. If anybody has any questions about these data pipelines and what exactly will be the next steps, please feel free to ask. Thank you.
Oh, hi. Can I ask a question now?
Sure.
Yeah, so I just want to clarify about the goal of the final model. So is it interpretability important?
Sorry?
Is the interpretability of the model important?
Yes, means that is yes.
Okay.
Definitely our goal.
Yeah, so in your baseline model, you use PCA as a compression, I guess.
Yes, that's what.
So yeah, after the compression, the interpretability is pretty much gone.
Means are you talking about the features that we are using for the model?
Yeah.
So means yes, interpretability is gone.
Okay.
But
Probably you could.
we're predicting we can do inverse transform, right?
Right. Yeah. So you're saying that maybe you could use the original feature after you get a prediction. You just put it back. I guess that should not.
We are going to put it back. We will be doing inverse transform because PCA, when you transform it, you can do inverse transform and you can get whatever you inputted it's going to give or convert everything back into that particular value.
Okay.
So we will be, if we are doing PCA, that means we have kind of like changed now the features are not features anymore. Technically, they are principal components. And at the end, we can in reverse or inverse transform it. And we are going to have the values the way we have in our data. Yeah.
Okay, so another question is about extrapolation. So do you see the potential that the target is the numerical might potentially get it extrapolated for the feature that we have not seen? I think that is a possibility.
That is what we are doing. We are predicting future values, yes.
Right. So for the tree ensemble, we cannot do the extrapolation. I just want to bring it up so we're aware of that. The limitation of the model.
Say that again. Which tree example?
Like GBM cannot extrapolate.
I'm trying to understand what do you mean by extrapolation? I know what extrapolation is, but
yeah,
in what sense you are?
Yeah, let's say I have not seen the data. Let's say the range of value can in the data set can be 0 to 100.
Okay.
So if the potentially in the future it could go beyond 100, it won't give you 100. It will stuck in that 100 if you go beyond that.
Okay.
Yeah, that is the limitation of the tree ensemble, regardless what. Yeah.
Yep. These what we can do is we can make an ensemble out of it, right? So we can because we can make several different models which can, for example, you are saying light GBM. Light GBM, keep one thing in mind. When I'm writing light GBM here, light GBM is used only as a feature selection tool. We are not using it as a model. When we are model developing, yes, we are developing so many different models. We don't know which one is going to give us best answers. If light GBM has a limitation like this, we can always now put it together with another model or ensemble it with another model, which can cover up that particular.
That's fine. I just want to bring it up. Thank you.
Absolutely. Means that would be, so right now this light GBM, this is used as a feature selection tool. This is not a model right now, which means at this step, light GBM, we don't care about its limitation. We are just using it as a feature selection tool. But model development phase, yes, these are the things because the whole month is about that. So we are going to fix, we are going to overcome kind of like the drawbacks of several other models. That's good that you are bringing it up, which means we need to be aware of it, and we can make an ensemble out of it, and we can use several or maybe another model along with it, which can overcome that deficiency or drawback of light GBM. Yep, sounds good. That's good.
Thank you. I think meeting limits, time limit about to hit. How about we just rejoin it, the meeting, everyone?
Sounds good.
Yep.
Yeah, thank you.
In progress.
Hey, hello, Simon. I had a question actually. For KNN imputation, are you making sure that you're not leaking any data from the tests from future?
Yeah. So that is where I think me and Rich were talking. And Rich, you want to talk about it?
Yeah. The initial run that we didn't take into account data leaking. So when we're building these 10 data sets, that's something that we'll have to implement. The purpose of our implementation for the first phase was that we did have a lot of beginners in our group, so we try to just do things as simply and as quickly as possible, just to get, you know, and try as many techniques as possible to get, you know, make sure everyone had a good understanding of what we were doing and why. But that was I raised with Salman that we didn't take that into account. We need to pretty much split the data before we do any of the imputations using the KNN and any of the scaling and the normalization as well. So when we're creating these data sets, depending on what method we're using, we'll have to put into place a split before we do any of it to stop, make sure the data leaking doesn't happen. It was a point that I did raise, and you know, it's well spotted. So yeah, whoever takes on whatever task, implement a step that will avoid the data leakage.
Thank you.
Any other questions, anyone? Please feel free to ask, discuss. Anything else you want to add, Rich and Salman, on this particular slide? Otherwise, I'll move on. Oh, you are not seeing it. Sorry.
I think if everybody understands what it is, let's keep it to that. Let's.
I have a question.
Sure.
Today is my first time here, and so for the part one, I want to know where the data is sitting, so that I can do those previous steps of EDA and all those pre-processing.
Mhm.
Yeah, everything we've done thus far is uploaded into our GitHub. Imran can share the link to.
So
to
I
look at
did.
it.
You didn't get it?
The GitHub, yes, I did see, but I only saw the template.
You
I
saw-
couldn't see the. Oh, 1 second. Let me check quickly. Oh, it was not letting me log in, I guess. It was giving me a 404, and then
Sign in.
Sorry, go ahead, Kaushik. You were saying something?
So you have to sign in into the GitHub to be able to access that.
oh, before okay, all
Yeah,
right.
it's a private GitHub, so you need to log in with the email that it's being sent to, basically.
Okay.
And you should be fine. If memory serves, I don't think the raw data sets are hosted on the GitHub. I think the raw data sets are in our project folder, which is in
I'll
the
cover
in the
shortly
Slack
in the
channel.
2 slides later on, 3 slides later.
Oh, cool.
Yes,
Cool.
I think we have the data here, right? I see train zip and
We're on GitHub.
yeah.
Yeah.
Okay. Okay. Thank you.
I think Salman had uploaded in the beginning, right, Salman?
Yes, means we have kind of like the raw data as well, and
Yeah,
we
this is-
have the one set of clean data which Rich uploaded as well in the Parquet format. So
Yeah,
right
sure.
now, so first week is about creating or generating the data pipelines. So we will be generating 10 data pipelines. And our goal is kind of like by the end of this week, we will have 10 different data sets to play with. And then the second week and third week is about model development, where we are going to throw in those 10 data sets into different models and figure out what is the best strategy or how we can end up with a good model. So right now, the data is in a raw form or what we used previously. But based on these descriptions that I'm giving you on the screen here, these set of steps, we will be creating these pipelines in this week. So that is the task of this week. But one thing, Imran, if you go back one slide, maybe one more, where you had a timeline. Yes. So if you look at the timeline, task 0 is generating the data pipelines, and next part is baseline model. So I would be providing you the data for the baseline models by the end of today. I will be making that pipeline, doing all the necessary steps. So the steps that we are going to do are on this PowerPoint. I think Imran would be uploading this in the project management folder. You can have access to it. That what would be the steps. Like Rich said, in order to avoid data leakage and everything, the splitting part and everything, I would be doing it in a step, and I will be creating or generating a data, and I will be uploading it on GitHub. So you can, in that particular 1 week, you can, until we have all the 10 different pipelines, the first data set, the baseline, you can play with it, you can try different techniques on it, and you can see that what kind of a baseline results we are getting. So that is our first week's task technically. And if anybody wants to jump in and help us out in generating or creating the data pipelines, or you want to create your own data pipeline, doing several different steps, or trying a different combination, because we did only 10, there are more possible combinations of the steps we did. So which means if you want, you can try those as well and generate a different data pipeline, and maybe that's going to give us the best results, and we have not explored it. So play with the data, go and take a look at the notebooks that we have already put on for the previous task, what exactly we have done, what our insights are. If you feel that there is something we did not do right or something we missed, please bring it to our attention. We want to kind of like update it, and we want to correct it, and we are all learning here. So I would recommend you go and explore. So this 1 week is technically for you to catch up and jump into, so that in 1 week, everybody is on the right page or right start, or we can all start from one particular point. Sounds good?
Yes.
Okay. Any other questions, anyone?
I think I'd just like to say as well, when we're running these data pipelines, if you look through the pre-processing, if you look through the EDA and the feature engineering, if there's any techniques that can be improved on, or there's new techniques that we haven't covered that will deliver a better output, feel free to add it, feel free to let us know, and we'll implement that. As I say, the first couple of tasks we tried to implement as many things as possible, just to for the learning experience, and I am aware that there's a lot of people who have a very high level of experience. If you could share your knowledge and either implement new things that we haven't tried, or correct us on some things that we've tried and hasn't gone quite as well, please do it for the benefit of everyone.
And I want to say one thing. I think, Diana, you tried TPOD, I think. And explainability is kind of like you were saying that you are not able to figure out which features it selected and everything. Maybe I would recommend try Shapely explanation or explainable AI. Search for it. There is a SHAP SHAP library, which kind of like breaks down the kind of like the black box models into explainable models. So maybe we can try that in order to explain the what TPOD is doing, because it is using genetic algorithm, and genetic algorithm is kind of like just like neural networks, a bit of a big black box, hit and trial different feature selection in order to get an optimized results, or keep on doing mutations. So we don't know what is happening under the hood. Maybe SHAP, while you can, because SHAP is a very good tool for explaining black box model. So you can try it maybe. And I would love to see what you come up with. That would be amazing.
Yes, absolutely. So this is Diana. Thank you for your suggestion. Actually, there's also an alternative. There's also Lime explanations. Don't know if you know that.
Yes, I know that. Yeah.
Okay. So I don't know exactly what the difference between the two is, but these two are options, I think, to make black box models available. But so the TPOT, it's just so genetically, it means that it performs random mutations, so to say. It changes one hyperparameter and checks the result again, how good the model performs, blah, blah, blah. But whether your model that it returns is explainable or not, it will depend on the type of the selected model. So if TPOT has detected a extra trees regressor, I don't know, to be the best, it can still be that you know how the predictions are calculated, right? So that you have the, yeah. I have another question, actually.
Sure.
But you can go ahead if you want to answer something more.
No, go ahead, Diana. Feel free to ask.
Yeah.
Okay, so I have a question about your simple imputation versus KNN imputation. So this is all about how you handle missing values, right? So by simple, you mean just by like extrapolating, so in a linear fashion, just
means simple imputation, we are just using maybe either the mean imputation or mode imputation or median imputation.
Did you mention here?
Okay. Because, I mean, with all of these 10 columns, you are suggesting that we should use the same imputation technique for all variables, but to me, this doesn't make sense at all.
I'm not restricting you to do that. So there are so many different possible combinations. There are so many different techniques. We are sticking with these 10 for at least this part. But if you are trying something new, we want to know that. So do try it, yes.
Just to understand, because I've missed part 1. So there was a team, or it was part of your part 1 work to explore where values are missing and why, and how these variables relate to the the variable to be predicted.
That has been done in the EDA part and pre-processing part. We have done a very extensive EDA.
Exactly, because this should guide this decision, no? I mean,
yes. So that's why EDA is somewhere here. So based on EDA, we have already corrected a lot of stuff. This simple imputation is going to kind of like fix whatever needs to be converted into because there were total 5 or 6 columns in total which had missing values, and majority of them had more than 50%. We just kind of like, because we cannot fix it, and majority of the values in it was 1 or 360 or something, so we kind of like just dropped them because more than 50% or 60% is too much of the data that is missing. And when we did feature selection part, they were not getting as much importance, so we just dropped them. So since that has already, so there are very few columns, 1 or 2, maybe one is site EUI and no, not site EUI, I think Energy Star Rating and year column. Year column had only 1800 values missing. We just dropped those values because we had 77,000 total values, so dropping them was an easiest thing. And then there's just one column is technically we are looking at, which we need to impute. And in that, simple imputation in KNN is what we try. If you want to try something else at that step, please feel free to go and try that, because we want to see different results as well. Yeah.
And which one is this column?
Sorry, say that again.
So you say just one column needs imputation. Which column?
I'm not talking about the columns on this slide. I'm talking about the column in the data set.
Yes, but what's the label of this column? What variable is it?
Star rating.
I think.
Yeah,
yeah,
okay.
Star rating and year. There was the year as well. That was missing a couple of values.
Yeah.
Year built.
So year built, we dropped it because there were only 1800 values. We dropped all those rows. So which means we ended up with just one column, which is Energy Star Rating, which needs to be imputed. Other than that, everything had the data. Yeah.
And did you do all that in one notebook that I could just go through and see?
We did it in steps, the pre-processing. So if you go on the GitHub, it
Yes.
has task 1, task 2, task 3, and it is going in a very proper sequence. And that's why we are allotting 1 week to this particular data pipeline thing, because we need to put these steps in this particular order in one notebook and create data pipeline number 1. And then the next steps in the next column on this PowerPoint right now, and create a new notebook, which is going to give us data pipeline number 2, and so on. So that is what we would be doing this week. But right now it is pre-processing is in a separate notebook, EDA is in a separate notebook, and feature selection is in a separate notebook, but we will be combining it this week.
Okay, perfect. Thanks a lot.
No problem.
I think we should move on. There are a few questions. I'm pretty sure once I'll cover other slides, I'm sure it will give more clarity to participants. In terms of model development, I think we covered. These are at least the few of the ones which we will definitely develop these models. And as we all mentioned earlier, me and Tasli, it's like if somebody has expertise, they want to bring in more models which they think which could be we can test on. So feel free to share, and then we can always add more on this list we have. In the end, tentative plan is to maybe pick the best 3 among them, and then see how it goes in terms of deployment. And data set is in GitHub, which I'm going to cover in a later slide. And then, as I covered earlier in model evaluation, these are the matrix possible: R-square, MAE, RMSE, and MSE. But so far, based on our part 1 approach, we realize I think MAE is maybe more applicable or maybe more suitable for our needs. But we can consider the other metrics as well. It doesn't hurt. So those options are definitely there. And in terms of deployment wise, pretty much let the team decide. I'll ask you guys if somebody has expertise and for whether we should deploy in Streamlit, Power BI, Tableau, or maybe AWS. So feel free to pitch what the way it works. Okay, so the way things works, those who are new, especially in this part 2, what we do, we usually break down our task. Like we assign, usually let people take the lead if somebody is experienced. So usually we have positions for each task as a team task lead, followed by there's a co-task lead. So they both work hand in hand, and Slack channels, they are kind of considered as subject matter experts. So if somebody has any queries, they usually address, and they kind of helps guide the team on how we should approach the route. So as far as in our part 1, we had few lead positions in which so far Salman and Rich Gregson were taking lead on the task leads, and they were doing pretty good job so far. So this why they were carried on into this one as well. However, in this part 2, we know there are many experienced professionals in this part. So if you think you have a more expertise, message to me in privately or something. So we have a different task lead channel where we discuss things on how we want to approach moving on. So we can add you in that, and I'll officially announce as well. As far as model, so for specifically for model deployment, we don't have any leads, neither Rich and Salman on that. So if somebody wants to take lead, there can be 2 positions. One is task lead and the other is co-task lead. If you have any experience from industry, maybe from AWS Cloud or Google Cloud, Power BI, Tableau, Streamlit, so let us know. And then there are a few leadership positions available in this task or in this whole project. So feel free to reach out to me, and then I'll tell you what positions there are and then how to approach it forward. And final will be the final presentation. But in this last part, in part 1, once we did our 3 tasks, which is data pre-processing, EDA, and feature engineering, those were the 3 main tasks we did in part 1. We reserved last week for the final presentation, in which we'll ask all participants to present what they have learned. And it was a great learning experience. Everybody had to present what they've learned and explain why they did what they did. In this particular part 2, we will be deploying, and then whoever will be the leads, and they will giving the presentation of how they were deployed. So I guess that will be covered in a final presentation. That's how so far we plan to approach. As far as membership rules and guidelines are concerned, main tasks are predefined, as we just covered in previous slides, and everyone will be free to join any task they find best. So which I said earlier, it's like becoming a volunteering to become a task lead or co-task lead. But again, it's not like a task lead's position is given to everyone. I mean, you have to prove yourself, and then if you can add value, that's great. You'll be tested. Otherwise, if you can't, then you will get other participant who can replace. I mean, because in the end of the day, that's a matter of it. This position requires a lot of responsibility and accountability because everybody's time is at stake. So we have to be responsible on who we choose. But I highly encourage in terms of learning wise to become a task lead, and you will learn a lot. And that sense of accountability is a great thing, best thing can happen. So please step up if you think you have the experience and knowledge to share. English will be the main source of language on Slack, yes. And I assume by now everybody should have got the Slack access. I've added everyone on Slack and GitHub, but if somebody hasn't, please message me as well, and I will take care. Yes. Those who are new to Omdina, it's like Omdina is a platform where this education happens through collaboration on real world problems, and AI for energy is one of them. And Omdina is in 50 plus countries, and there are 10 plus projects per month, and there are many more happens all across the globe, different kind of projects. And there are in different, depend on the thing. In our case, there are 60 plus participants there, so you get an opportunity to work with different kind of people with different sets of backgrounds. So it's a great platform for anyone to have, whoever is planning to go or take a route towards AI and ML or data science journey to work on this real world problem. Join the Slack. As I said earlier, I've already sent out added all the participants into Slack. If somebody still aren't able to access Slack, feel free to message me, email me. And as far as some of the resources are concerned, we briefly mentioned about the GitHubs. I'll be sharing this slide as well, so you can go over this access. So here's the GitHub. This is under Omdina AI, Philadelphia. That's our chapters page. And sources, there are different tasks. Each task is very clearly defined. Task data pre-processing. There are notebooks already.
Can you open the data file once? Just quick look.
This?
Just the data file, the source data.
Oh, data file. Well, there's a project management for. I'm going to cover that as well. But you mean here?
Yes. There's a CSV file, right? Some CSV.
Yes. I'll show in the next one from where this actual data file came from. So that's the second thing I'm going to cover. But this is where the GitHub stuff, where all task specific stuff is there.
Imran, in SRC data, you have zip files also. That
Okay.
is in data.
Oh, sorry, my bad. Okay, that's what he was referring. Yes, okay. Yes. So over here, and there's another link as well in which there are. So, yes. So one thing to add, we in this test file which we originally got for this project, we are not going to use that. That test data has a lot of missing values, and has a lot of flaws. So what we end up doing, we'll be using as a training data, and from that we'll be splitting some portion as a test data. So ignore this one. That's the one we just used in our.
Technically, in the test data, the target is missing. So we cannot do anything about it.
Yes, thank you. Yes, that was the main point. Yes.
Oh.
So you guys talked about that some of the features were already dropped and some things were based upon the exploratory data analysis. Do we have a data available from that so that we can directly use that, or the idea is to use the pre-processing notebooks and from there use the code and do that all over again? What I'm trying to say is, has a CSV file data dump been created from the trained data set that has been available, and all of those base imputations or something that has been done that we, not the ones that we were talking about like KNN and not the evaluatory ones, but the basic ones where some of the columns were dropped because the data was not available, or 70% of the data was missing. Do we have a baseline data set from that, like a first baseline data set that can directly be used for going into the imputation and other modeling phases?
Yep, Nukta, that is what I was saying, that I would be uploading the baseline data today.
Okay.
By the end of today, you will see a message on Slack. When I upload it, I will send a message on Slack that the baseline data is available and you can
I
go
see.
start exploring. Yeah.
Okay, thank you.
No problem.
So feel free, GitHub link will be shared. It's already here. So feel free to look around what's in each of those folders to get a sense of where we stand. And there's a task specific notebooks as well. So just an example, this is one of them. Well, this is not full, so let me open. There are already notes and everything is mentioned, commented out as well. So you should be easy to follow through, even whatever your background is. You should be able to understand what the logic behind doing every process here. So take a look of all these. There's a PCA as well, quantile refreshing. So feel free to take a look once we're done with this meeting. Okay, and then
how many columns are there? Okay. Okay, I will take a look. Yeah.
I think that would be helpful. So we also have a project management folder. I'll be adding more of these task related stuff, but what we do, initial data was here posted, whatever the stuff related to each specific task, like let's say over here, there are a bunch of videos. After this meeting's end, I usually post it here. And then Rich, we also have a YouTube channel in which he just combines, merge all these videos into one video and he uploads. We have a YouTube channel. So whoever is new and they are curious what we have done previously and all throughout the task, project, part one of this project, they can watch all those videos. It should be in a 2 days time slot. They should be able to finish and then can keep up if they really want to learn those stuff as well. Everything you need pretty much is here given in terms of anything task specific in terms of videos wise are here, and anything in terms of problem statement is here. There are some kickoff presentations, like whatever the important stuff so far we have covered, everything is here. There are important links as well, and tools and documentation. So feel free to take a look. So there's a GitHub link already here. So it's your one-stop shop. You can find everything pretty much. And there's a YouTube link, which I'll share it as well with you all. Here, these are the GitHub links. There's a Google Docs stuff which will tell you whatever task specific stuff, whatever the important links there are, they're all compiled, like related to data pre-processing. There are all the useful links, which articles which we read. You can always add more, but these are the main ones which we read, and as well as for same for exploratory data analysis as well as for feature engineering. So there are task specifics. Stuff is already here. Let me give you a quick glance. See, these are all task specific. So if you really want to learn something more theory or how to get more knowledge about task specific stuff, you can read from this link as well, and you should be able to get a good sense on what we did. Okay, and then well, on Slack there's a discussion channel. So these are the different channels and what they are there for different purposes. So feel free to read that once this presentation ends. I'm going to share this PowerPoint slide into the project management folder, and this project management folder is in our Slack on I would say, I think in a problem statement channel. That's where this project management folder is. You should be able to see on the top bar on the bookmark on top. One thing to add, today probably I'll be adding more channels, one for model development, one for model evaluation, one for model deployment. I assume you guys may not be added by default, so you guys have to add yourself. I'm just curious, last night I created the model development channel and I selected add channel. So did you all get the notification? Did anyone of you able to join? Or anyone of you?
No notifications.
No notification?
No.
Can anyone of you actually right now, that'll be helpful, like search right now on our Slack channel, any of the task leads, if they can able to add onto model development channel now?
Yeah.
I see only one module development, right?
That's fine. I was just as a testing.
Yeah,
Yes,
there is-
we can join it.
We can join.
Okay, good. Yeah, I'll send out the announcement as well, so you guys should be able to. Good. Well, thank you all, and please stay in touch through Slack. That's our main mode. So if you ever have any queries related to task specific, so we have different task specific channel. Let's say model development, model evaluation, and model deployment. So in this particular case, we'll be dealing mostly with model development. Feel free to ask any questions, and anyone is welcome to answer. And we usually work with more in a collaborative sense, and usually try to promote a good sense of discussion, so at least to enhance our learning experience. So feel free to ask. Give me a second. There's a bunch of messages on my chat, so I don't know. Do I need to answer something? Okay, I guess it's covered. So that's good. Thanks, whoever responded. Thanks, Komal.
Thank you. Yeah.
Okay, any questions, anyone? Can't hear you. Can anybody hear him? Kaushik, can you speak louder? Hello? Like, Kaushik,
Yes. Yes.
you were saying something, right?
No, I said I'll take a look at the data files and I will keep you updated on Slack.
Yes. Feel free to ask any question. Thank you. Yes, sure.
Yeah, I think at this point we're just gonna. I think if everyone could go away and try and create their own data pipeline individually, and then on our next meeting we can talk about the data that everyone has created and what kind of results they've got. I think that's the best way to do it, and just keep us up to date in Slack. And as we said before, yeah, just be mindful of any data leaks when we're running through the process, because that isn't something we implemented for the sake of easy, showing people how things are done. So yeah, just keep that in mind as we build the data sets.
So yeah, thanks, Rich. I agree with that. There's one thing to add. Sorry, go ahead.
Yeah, hi Imran. This is Benita.
Okay.
I had a question. Like, you have different tasks for model development and model deployment. So would all these tasks will be parallelly going to start working on something like model deployment team? Are they going to do anything on week 1?
No, not really. Those are the channels that I'm gonna create beforehand. But currently, we mostly will be dealing for 1 week. It will be model development related. So you can post any queries over there for now.
Okay.
Like after week 2, it will be for when we'll be into model evaluation time. So you just ask your relevant question on that particular channel. That's all.
Okay, got it. Yeah. Thank you.
Any other questions, anyone? Please feel free to ask. Get a good clarity. Once you have good clarity, we help you.
So week 1, we are not focusing on model development, is it? Like it's only about data pipeline, coming up with the data.
Yes.
Yeah, that's right. Yeah.
Yes.
Oh, okay, fine.
So here's the thing. One thing I would like to let newcomer who are joined at this time. So what we did in part 1, whoever volunteered to be a task lead in this particular and part 1, it was Rich and Salman Khalik. What we did, we keep those guys accountable. So let's say from Wednesday till next Wednesday, there's a whole duration of one task, right? So what happens, we ask them to deliver up to 60 to 65 to 70% of their coding till by Sunday, because there are 2 meetings. One meeting is on Sunday and one is on Wednesday. So our Sundays meeting are slightly longer than the Wednesdays one, because Wednesday is a weekday. So what they share those coding stuff. So in this particular task as well, they, as Salman briefly mentioned, and out of these, there are 10 altogether, right? So what's going to happen? Salman said he's going to send it one of this by tomorrow. So like from end to end, from data pre-processing, EDA, and simplification, like all the way from top to bottom. And he will message us on Slack, right? Now, if any one of you who want to get a sense of how they have done and all that, so you can just go to open that notebook and just take a look on that by Sunday. So at least you can get started to just get a sense of how end-to-end they have approached. However, by Sunday, they will deliver us at least 4 to 6 out of these. So maybe at least 2 from these in the yellow ones, and the 2 from KNN ones regions as well, end to end. That's their deliverable, because they are, once you become a task lead, their responsibility comes. So what's going to happen when we meet on Sunday, they will tell what they have done and they will elaborate further. But at the same time, while they will be making progress, it will also give us, all the participants in this group, an opportunity that they can, if they can, I mean, they can also get as a reference what they have done, and they can do their own things as well. And they should be able to share also with the team what they have done. Maybe they've tried out something different, they can share with the team on Sunday's meeting, and this way we can all just make progress as a one team, rather than a few individuals make progress and others stay clueless. But our approach is always like to grow as one team, learn as one team, by the end of the project we all know A to Z what we have covered. So that's just one of the approach. So that just FYI, they will be delivering these at least 2 from here and at least 2 from there. So far my expectations are 3 from each side by Sunday, and I'll be in touch with them afterwards. So that's just FYI. And as I covered earlier, there are, for model deployment, there are a few task leads as well, positions and co-task leads. So if somebody has experience on deployment wise, feel free to message me. We can add you as an official task lead as well. And being a task lead has its many perks as well. I'll cover that once you sign up for that. And also, yes, that's pretty much it in my agenda. Any other questions, anyone? It's getting late, I know it's Wednesday. Okay, well, if you have, feel free to message me if there's any more questions or concern. And if you have any question, otherwise we're going to wrap up in a minute.
Okay,
And
Please go ahead.
the target variable, right?
Sorry?
Energy star rating is the target variable.
No, EUI
No, it's
is the
the,
target
EUI.
variable.
Yep, the site EUI.
Oh, okay.
I think it's, in the very raw data, it's the second to last column.
Second to last. Okay.
And on what hour on Sunday? Is it like something fixed?
So, okay.
Any
Meeting
EST?
times will remain from 9 a.m. till 10 a.m.
Okay.
Eastern Standard Time. And just a heads up, because of sometimes the content is more, so on Sundays we usually stay slightly little more than an hour than on Wednesday. But on Wednesday we try to restrict till an hour. So, but timings are 9 a.m. till 10 a.m. US Eastern Standard Time. Right? Any other questions, anyone?
If you have any questions about the content in the notebooks, feel free to reach out to me and Salman, and we'll go through them with you, just in case, just to avoid any confusion.
Yes, thanks, Rich. Thanks for offering that. Yes, feel free to post on task-specific channels.
Okay, and can I ask another question?
Yes, sure.
So what is our task for Sunday? To take like the simple implementation and to implement one hot encoding and the PCA?
Yeah.
Mm-hmm.
Like basically from end to end, Salman will be posting one of this standard base model.
Oh, so Salman gonna do the first one, and we can try few others.
Yes.
Yeah.
Zoom ಅಲ್ಲಿ ಕಟ್ ಆಗೋಗುತ್ತಲ್ಲ 30 minutesಗೆ ಆ ತರದ್ 3ನೇ ಸತಿ ಜಾಯ್ನ್ ಆಗ್ತಾ ಇರೋದು.
Yeah, in answer to that question.
I think she's not here, Rich.
Oh, isn't she here? No.
She has not joined yet.
No, she isn't. But yeah, for everyone else on the call, Salman's going to upload the baseline, and then from at some point today, later on tonight, and then from there, if everyone can work on, pick one at random and work on it, or work on one that we haven't covered, and then by Wednesday we'll have some to discuss, and by Sunday hopefully we'll have them all. Oh, sorry, the other way around. Sunday we'll have some, and then the following Wednesday we should have them all.
Yep. Okay. No, I think we should wrap up now. That's.
Yeah, we'll jump off this call, but I think reiterate what the plan is in Slack in the appropriate channel, just to make sure everyone knows where they're up to.
Yep, that sounds good for sure.
Cool.
Okay, thanks guys. Thanks for showing up, and have a very good day. Take care.
Yep, have a good one. See you soon. Bye bye.
Thank you so much.
Thank you, guys. Bye.